So let's say how this would work if I gave you a question, I'd probably have to give you a graph like this. Okay? Wave function versus x. And then I would draw something for you. So let me just make up something, okay? Let's say I gave you that. I would want to know things like n nodes and the wavelength, okay? So, the easiest thing to start off with is always nodes. So let me label those. They're anything that intersects the axis in the middle. So you see there's 5. See that where I put the big dots? 5, so there's 5 nodes. You know that nodes is n minus 1, so you just add a value of 1 to that, and you can get n, which is 6. Great, 2/3 of the way there. Last one. Lambda is 2L over n. Let's put that in. So now that I have n, I can get lambda really easily. 2L over 6 or L over 3. Let's see what that means. In 1/3 of L, I should see one wavelength. And I do. And then I see another one in the next third and another one in the next third. So that's what that number means. I'm seeing that. One wavelength in the distance of L over 3. There we go. Cool. Okay, we'll rotate around. I just want to make sure other people get that. Unless you have a question on this. Wait, what else is there?
It's like 66 in the reader, but it's more so like tangent or trigonometry.
Yeah, the trig functions I didn't cover because you're not going to use them. They're just for fun to show you what this wave is. But I'll give it to you on the exam, but you won't use it. It's just there for fun.
Okay.
Is that cool? You're happy? Good. All right. Yes. No worries. It's just I wanted to show you where these things, what they look like mathematically. Yes. You were next. That's cool.
How does that, how do you get 5? How is 5 over 2 also? I understand how it's L over 3, but how is it?
Can I see the example? I don't remember what I was doing. Okay. Pass it on over. Yes. Where am I looking here? Oh no, the answer for this one was 2L over 5. Yeah, that's it. Erase that 5/2, whatever that is. Did that answer your question? Okay, yes.
Wait, so for this one, if they gave you L, would you plug it into L over 3 and then multiply it by 3 so you get 3 full wavelengths?
If L was numerically given, and you were asked what?
To find the wavelength.
To find the wavelength. If L was numerically given, give me a number. 2.5, then the wavelength will be 2.5 over 3. That's it. Cool. Yes?
Do you always have to cancel off the units to get full credit, or could you just put meters
Oh, for when we did the Heisenberg question, how would you do the units?
to get full credit?
How would I do the units? I would just write down meters.
Oh, okay.
Yeah, but the reason I went through it, one, just so you could see how it's done, but those are the kinds of questions I would ask you the units. How I come up with a question is I would I just pick a random formula, like, oh, let's do Heisenberg this quarter. And then, let's get through this page. And then I just write this down. So you don't know it's Heisenberg, but that's where I get the units from. And then I have you solve this not knowing where it's from, and you have to come up with meters. Okay? Yes, over there in the corner.
Sorry,
Yeah.
I don't know if this has already been asked because I couldn't really hear, but why, I know that I've seen the equation 2L over n in the reader, but in this case, aren't there 3 wavelengths within the length from 0 to L? So
That's right.
It would be 3 L? I'm sorry, I didn't hear.
Yeah, you're looking at it from the reverse perspective, which is, what's L? You're totally right, there's 3 wavelengths.
Okay.
But if I want to solve for this one, it's L over.
Okay.
It just depends on your perspective. Good, yes? Okay, practice exam, what page? 96. number? Number 17, what parts? This one, liquid nitrogen? Okay. Do you want me to just go through the whole solution on this? Okay. Liquid nitrogen is poured on balloon filled with argon, causing the balloon to contract. What's the approximate? To what approximate fraction of the original volume will the balloon shrink? Which is cooled from 22 to 120. That's what I want. So you go from 22 degrees C to minus 120 degrees C, right? It does not tell you the volume. So what's your favorite variable? What's your favorite variable? No, joules is a unit. I need a variable. I like the letter. Give me your favorite letter. Okay. All right. So there's one gas, and things are changing. So I would use gas law. Okay? But notice, if you read the question, they don't mention anything about moles. Presumably it's the same. And they don't mention anything about the pressure. So presumably that's the same too. So I'm going to knock both of these out. And so I have, in fact, Charles' law. The initial volume is C, your favorite letter, divided by T1, 22 plus 273. The final volume is what you want to know. Final volume is what you want to know. And then the final temperature is minus 120 plus 270. Is that okay? Solve for V2. Cool. And then once you get V2, V2 over V1 is a fraction that it has shrunk, which is essentially what they want. What approximate fraction of its original volume did it shrink? This is what's looking for. Okay, who's next? Yes?
Okay, as a short answer question, you're given a random number of velocities and find the square velocity.
Can I see?
Yeah, number
17. Oh, will I do this list here? Okay. Oops, excuse me. This is, whoa, a really old reader. Winter 2013. I give you this. It's number 17. I give you 3, 4, 5, 9, 2, 6, and 4. Which one of these did you want to solve? The average, the mode, the mean, the root mean square, all of them? The root mean square velocity, if all of these are velocities, the root mean square means this, the square root of the squares averaged. So how do you do that? Well, it's a square, make a huge square root. It's 3 squared plus 4 squared plus 5 squared plus 9 squared plus 2 squared plus 6 squared, everything squared plus 4 squared. All divided by the total number, 1, 2, 3, 4, 5, 6, 7. The average of the squares, whatever this number is. Is that okay? Okay, cool. Who's next? Yes?
I think it's number 15. I have the key here, but I just want to see why you have to do like the square root
Winter 14. Winter 14, number 18. All you don't understand is the square root.
Yeah, like how.
This right here.
Yeah.
Well, and was squared initially, so I have to invert it, and then I'd have to take the square root because it was squared. That's the only part you don't understand.
Yeah, I guess like, I know like you like plug it in and stuff, and then like use the absolute value of like E. I guess just like finding an F out of like that.
Say that again.
I guess the only issue is like trying to find the end of F and like converting that into that.
This step to this step.
Yeah.
Okay? 1 over n final squared equals minus 1 over 8 squared. So this is kind of an algebra questions over the Rydberg constant. Okay? Oh, you can see that? Okay? So it's kind of an algebra question. Well, 1 over n final squared minus 1 over 64 equals the absolute value of the energy over the Rydberg constant. Add 1 over 64 to the right-hand side. Over 64. Is that okay? Now, I need to invert this. So I'm going to remove this. Is that okay? I inverted both sides. Now I have to take the square root. Is that okay? That's what they did here. Just kind of like putting all those steps together. Is that right? Okay, let me remove all this so you can kind of see that. I'll leave you here to stand that. Next. Yes?
Yeah, I have a question about
Winter 2011, number 4. Winter 2011. You can ask me afterwards. This is one of the kinds of questions that won't be on the exam. No, because this is solving for a rate finite value bar. But you can ask me later. I'd be happy to talk about it. It's fun. Yeah, that's what I said. It's not on the exam. So you can ask me afterwards. But since it's a review, I won't answer it here. Is that okay? So ignore it. Okay, cool. Yes? Fall 14. Fall 14, number 17, what part? Part 5, right here. Yeah. For this one, you see that we're dealing with a liquid. Is that okay? When you're dealing with a liquid, then the only pressure formula you know is this one. Density would be the density of water. Water. That's given on the back of the exam. Gravity is given on the back of the exam. Height is given in the question, but you need to change it to meters. Is that okay? Or should I plug that in? Okay. So density on the back of the exam is 1 gram per centimeter cubed. Gravity on the back of the exam, 9.81 meters per second squared. And this is 10 centimeters. You need to change this to SI units. So, which would mean, in a different color here, change this to kilograms, change that to meter cubed, and change that to meters. Are those conversions okay if I have you do those? Okay. If you don't get it, ask me. Okay, next, yes? Is it? Yep. Yeah, that you can ask me afterwards. I think that's a homework question, but that's past where this exam is. But I'm happy to answer that afterwards. Yeah. It's also, if you ever have a question about the silicon and you're doing the homework, that's, and you don't have a chance to get to me before the exam, you want to get it done, it's a video on our YouTube site. Yeah. And it's also explained in words in the reader, actually, for this reason. So if you're doing the silicon example, read page 82 in the reader, specifically part 2 on page 82. Okay. I can take a couple more. Yes. Oh wait, she had one for a while, sorry. Yes. 3 on page 98. This one? Okay. Which of the following is false? Okay. One, does this have 2 radial nodes? That's true. Let's see if I can draw them in here. One's here. You're looking for circles, right? Radial big circles. Okay? Does it have an angular node? That's true. It's right here. This is a p orbital. Okay, oops. Let's see what else we got on this one. If there's 2 nodes, I guess I should say, what's the total number of nodes here? 3. So n must be 4. Yeah. But L, that's right, that's 1. This orbital can only hold 1 spin of electron. Is that true?
Yeah.
Yeah. And what's the other electron it can hold? The spin down. Yeah, so 2 total. One's up, one's down. Yes? How did I know it's a p orbital? It has 1 leaf on one side and 1 leaf on the other side. Let me guess. If you get, I'll just move this over. There we go. That was a mystery. Okay, cool. Next. Yes, way up there. To get the molar mass. For what? How do you use the molar mass? Yeah. This is called a variance on the ideal gas law. And the 2 variant formulas are density is mass over volume, and molar mass is mass over moles. So you use these 3 equations and you plug them in. I think if you kind of mess with it, you'll get density, let's see, is pressure molar mass over RT. Something like that. But it depends what variable you're given. So I don't know, if you have density, you can use this. But you need a combination of these to derive the equation you need. Is that okay? Yeah. Okay. Yes? Density. There's a question here from the book where you use this formula. This one. Find the height of Mercury. How do you find the density? You look it up. And it's going to, I think it's 13.6 grams per centimeter cubed. But you can find that online on Google. On the test, I'd have to give it to you. Okay, next. Yes? Sorry, we're going fast. I just want to get to a lot of people. 8 on page 107 of the practice exam reader. Okay, this one right here. I wouldn't ask you one of these kinds of questions. Yeah. Cool. That was page 8, number 8, page 27. Next. Yes. Okay. Okay, do you have an example for me to try?
Not an exact one, but that's kind of the one that I,
Okay.
because this is an example here, is like, how do you get evidence X, A, in A over control, or X, P, over
Okay. Let's say we have 2 gases, helium. This is Dalton's law question, and hydrogen. Helium's about 4 grams per mole from the periodic table. This is about 2 grams per mole from the periodic table. Let's say I have 6 moles of this, and let's say I have 8 moles of this, okay? And I want to know the partial pressures of these. Okay, so we'll go through the whole Dalton's law. I know it's a Dalton's law because I have more than one gas in the picture. Okay, so let's start with helium. I would say, okay, oh well, I guess I gave them all. We won't need the molar mass.
Oh, yeah, because one thing was how do you find the molar when you're not getting it? I found
Oh.
in your YouTube video, but I kind of want to do more stuff.
Okay, let's do this. Grams, let's change them to grams. Okay, so it'd be 8 grams times 4 grams per mole, and that's 2 moles. For hydrogen, that's 6 grams times 2 grams per mole. And this turns out to be 3 moles. Is that okay? Okay. Now I want to get into the total moles and the mole fraction part. Okay. So here what I would do, first the total moles. I just sum these two up. 2 plus 3, that's 5 total moles. Now, let's say the mole fraction of helium. That would be the moles of helium divided by the total moles. The moles of helium is 2 divided by the total of 5. Or that's 0.4, and mole fractions don't have any units. The mole fraction of hydrogen would be the moles of hydrogen divided by the total moles. Kind of similar to the previous, and that's 3 divided by 5, or 0.6. Is that okay so far? Okay. For this example, notice that the sum of the mole fractions equal 1. So 0.4 and 0.6 add up to 1. That will always be true. All right. The next step would be to find P total. That's N total RT over V total. Unfortunately, I didn't give you those numbers, so we have to rewind for a second. Rewind. V, 10 liters. What else do we need? T, 300 Kelvin. Okay, if we're at 10 liters and 300 Kelvin, now we can do this calculation. So in this calculation, N total is 5 moles. R is 0.08206 liters atmospheres per mole Kelvin times temperature 300 Kelvin divided by the total volume 10. This will give you P total in units of atmospheres. I'll let you calculate that because I just made up the question. Okay? Then the next thing you want to do is say the partial pressure of helium. That's the mole fraction of helium times P total. So that would be the mole fraction of helium about 0.4, and P total, it's the answer of the previous part plugged in there. And, yes?
I'm sorry. So you would only find the partial pressure of helium and not hydrogen?
Oh, you're just too fast for me. I was about to write that down. Yeah. Just like 5 steps too fast for my speed of writing. And I thought I was going fast enough. Okay. Helium is equal to P total equals 0.6 times P total. Okay? I can't write any faster than that. Okay. Yes?
This is a general question for the exam. When we get dot points, we don't like add every specific unit that goes into like, for example, 0.0826 liters ATM over moles Kelvin.
What's wrong with that? That's what I did.
No, I'm just saying like if you just wrote down like the actual numbers instead of like the units that go with it, like SI units, when we get dot points.
Okay, if you don't write the units and you're just writing the numbers, will you get docked? I would recommend just writing the units. You're going to have one of our TAs is going to grade all 550 of one question. And you don't want to make them upset, confused, ticked off, etc. So the clearer you are, the better it is. And if you already know the units, you might as well write it. Yeah. Just to fully show that you know what's going on. Okay? Yeah. I know sometimes I don't, but it's better for you. All right, if you have any more questions, come on down and ask me. I'm going to start to pick up the